Hey guys, today we're going to be learning about the differentiation and integration of vectors. You might think, oh, this is going to be so different, but nope. What we've always been differentiating and integrating is pretty much the same thing in vector form, except with the addition of a few extra variables. So let's take, for example, that x of t equals, let's say, 3t, and y of t equals 4t squared. So we get our position. We put this in parametric or polar form to get r of t equals 3ti, because I is in the x direction, and plus 4t squared j, which is in the y direction. And to take the derivative, we just simply use the power ruler and take an easy derivative. So you leave the I alone because that's just part of the parametric form, and so the derivative, which is r prime of t, equals 3i plus 8tj. Notice the initial equation was a position formula, and since we took the derivative, this becomes the derivative of the position formula is the velocity. And if we end up taking the derivative again, we end up getting hj, and this is the acceleration formula equation. So to take the derivative of the position formula once, you get the velocity formula. If you take the derivative of the velocity formula, you get the acceleration formula. And now we're gonna go to integration of vectors. This is also really simple. Let's take that same example that we just used. X of t equals 3t. Whoops. And y of t equals 4t squared. So you want the integral of 3t plus 4t squared dt. And just like any other integration, you would separate these two. So it would be integral of 3t dt plus the integral of 4t squared dt. And so the integral of 3t is 3t squared over 2 plus 4t cubed over 3 plus c. So as you can see, integrating and differentiating is not that hard. And it also has the same properties as normal. And one thing to notice is that the definition of a derivative of a vector valued function is like the definition of the derivative we learned in the first few months of calculus. We have here r prime of t equals r of t plus change in t minus r of t over change in t. And I forgot to add the limit here, but it's supposed to be as the limit of change of t approaches 0. And then this is the definition of a vector value function too. It's not that much difference as the normal derivative. And one more thing, a vector can also have a third value, like you know how we do it in 2 dimensions. Vectors can have it in 3 dimensions. So it'd be x of t, y of t, and I guess you could make a variable h of t or something. And then it would be, and the variable for this we could make up a value 2t and it would be k. But if we did add that to the equation, it wouldn't be much difference, except that you just leave the k on there. Well, thank you for listening, guys. This is how you derive and integrate vectors.